Great to see you all here today. I hope you're all safe at home, able to work or study remotely during this pandemic that we're all in together. From this moment onward, everyone will think of the internet as something completely different than what we did before. People all over the world will remember the internet as the way they stayed connected to family and friends and work during lockdown. Kids will remember learning from home by Zoom, something they never even heard of before. We'll remember coming to this conference today via Big Marker and Slack. One thing this pandemic has shown us for sure is that the internet is critical and reliability matters more than ever. I wanted to start by saying a big thanks to everyone keeping everything up and running right now. Big shout outs to you all. For those of you on call, for those of you keeping the lights on for all the services that everyone depends on, thank you so much. Today, I wanted to start by sharing one of the craziest incidents I've ever experienced. Has anyone ever heard of ATMs spitting out free money? I have. I hadn't heard of this until I graduated from university and got my first engineering job at the National Australia Bank. At the time, there were heaps of news articles about ATMs from all of the big banks giving away free money. We all know that outages cost money, but this gave a whole new meaning to it. Our ATMs weren't just not working, they were actually bleeding money. Do you remember your first time on call? This is a picture of me for the entire duration of 2009. I started my first on-call shift in January 2009, and it didn't end until February 2010. To set the scene, I was on call for a company that had been recently acquired. It was a mortgage broking company called Homeside, and it made a ton of money. It was a very successful business. When I accepted that job, I was really excited to help people move into their dream homes. I love the idea of helping people get their own place. The guy who sold me on the job seemed to really know his stuff. I was excited to work with him. I wanted to write code. I would happily sit at my computer for 8 to 10 hours straight writing code for my university assignments. But I didn't have any real users, just like 1 or 2 friends that would use my apps that I built. I was excited to help build useful services on the internet for real people. I packed up my entire life in my little car and I drove 19 hours from Brisbane all the way to Melbourne, crossing 3 states for my dream of helping create the internet. When I arrived, a fresh-faced young grad, I found out that my boss had quit a few days before and he'd taken the 3 senior engineers on the team with him. What a blow. I was told that I just needed to get stuck in and start learning how to improve the system with the remaining 3 engineers on the team. Talk about sink or swim. This was like forge your success through fire and pain or just pass out trying. I'm not one to give up, so I got stuck in. I worked 7 a.m. to 7 p.m. from the office, and then I went home and worked all night long too. That's what some new grads will do. We were able to keep the lights on for a few months, but I actually never had any time for lunch, and all my friends used to make fun of me for it when they were on other teams that were doing okay. But you know, all the systems were operational, and we were keeping the internet up and running, and people were moving into their dream homes each day, and that made me feel good. Then one day, there was a huge outage. I was on call at the time, the number 1 person responsible. I saw all of the mortgages slow to a complete standstill. This was my face, like, oh my gosh. I worked hard to get things back up and running. We were having an issue with Apache and our database at the same time. Nightmare scenario for a new grad. All systems were actually then go. I was able to fix the issue. Luckily, I'd been working on Apache and working with our database for the last few months, and I knew how to resolve the problems there. But, you know, it was a really hard thing, and I knew there was going to be consequences. People get really mad if they lose their dream home, and the way that the mortgage broking industry works is you put your mortgage deal in that you want to get, but if it doesn't close, then that means someone else will get that mortgage and they'll get that house instead of you. So the next day, sat down at my desk, waiting to see what would happen. Somebody walked up, tapped me on the shoulder, and I turned around. It was the CTO. It's really big and tall, like this high. I was like, oh no. And then he told me in that moment that there was a fine against my name from the ombudsman and the regulators for the outage. Dang. In that moment, I knew that reliability was critical and I needed to learn more about it. I stuck my heels in and I worked harder. So this is an interactive talk. I encourage you to ask questions and drop comments in the Slack, just like you would if this was a Twitch stream. If you haven't yet joined the Slack, head over to slowfile.com/slack/Failover Conf. Each talk has its own channel. The channel for this talk is QA-Tammy Butow. Go ahead and join the Slack now. You can find me in there. I'm Buttons. I'm Tammy Butow. I'm Australian. I love setting goals and crushing them. One of my first ever goals was escaping Australia. It's a dangerous place. It took me many years, but I made it. I finally moved to Florida in the USA. Nothing to worry about here. I love building fun side projects in my spare time. You can check out my GitHub for a project that I built recently called Chaos Quest. It's a fun chaos engineering game that you can play with your team. It's super remote friendly. I've shared 6 chaos engineering scenarios that you can run with your team to help them learn about chaos engineering, like limbo mode and peace mode. So I work at Gremlin. I've been here for 2.5 years. Gremlin's a reliability company. We're building a chaos engineering platform to help everyone be prepared for the moments that matter. You can check it out at gremlin.com/gremlinfreesoftware. Give it a go and let me know what you think. So I wanted to ask you all a question. How did you first work on reliability? Do you remember the moment when you first thought, wow, this just doesn't work like I need it to? I was lucky enough to get the internet at home in 1995 when I was like 11 years old. My parents were super cool with me being on the internet all the time. It's way safer than being outside in Australia. I was getting into MUDs, reading all these web pages, but the internet was so slow. It's notoriously slow in Australia. If anyone's ever played Stardew Valley, there's this part where you've been farming all day, working really hard, and then you just get really sluggish from overworking yourself and you move around the map like in slow-mo. That's what the internet felt like 24/7 in Australia back in the 90s. It's not much better now, to be honest. But those experiences made me want to build a better internet. I saw the potential. I just really thought that the internet needed some TLC. So when did you first realize that reliability mattered to you? What actually happened to you? And for those of you asking if I play Animal Crossing, actually, I'm a big Steam fan. So there you go, Stardew Valley. So to be successful, you've got to have a vision, right? My vision during university was to build awesome features that everyone would love. My friends would think they were so cool. They'd use them all the time. They'd work blazingly fast. I was like super pumped. I love getting pumped up about things. And my mom was just really happy the whole time. She just really wanted me to fix her iPad. So, you know, one of the very first shiny new features I got to work on when I got to the bank was a web app for brokers to be able to view all of the mortgages that they had in progress for their customers, rather than having to like call up the bank or go in and visit a branch. And I thought that was pretty cool. Like, let's move things online, make it easier for everyone. But whatever I did, this new app was always slow because of the cache, because of the database queries, because of the database, because of the hardware, because of the network. I just went deeper and deeper and found more and more problems. It was just rough. So, you know, for me, for my first few years working in technology, it really felt a lot more like the bottom right. Pain, late nights, tiny teams that don't even have time to build features. I was spending a lot of my time fixing all of the broken issues that had been there for a long time, and I didn't really have that much time. So I think I actually went from fresh-faced, young grad to salty IT guy in 1 month. I started thinking more and more, though, about the concept of reliability. Availability, durability, performance. I was noticing problems everywhere, at work and at home. This game is slow. I can't connect to this server. I'm missing shots in Counter-Strike because of lag. Enough is enough. I wanted to build features that people loved and raved about, but if nothing works, what's the point? To me, I think being an SRE is a lot like being a detective. I decided that I was going to get to the bottom of this reliability problem I was having at work. I started out by putting a map together of all of the people I needed to identify the case, to solve the case of missing reliability. I was told, go and talk to this guy over in the mortgages department, then go and talk to this lady in networking, then go find this guy over here in databases, then find this lady in the data center across town. She's really helpful. I think I went to visit 6 different office buildings and data centers in 1 week. Someone for the kernel, someone for the firmware, tons and tons of issues all over the place. But in the end, I had made this giant map that plotted out all of the key players in this case for missing reliability. Has anyone ever felt like this is what happened to them as well? And then I finally came to the solution. All the key technical players were now on the same page. We all acknowledged that reliability was feature 0. Everyone agreed. If nothing works, what's the point? But then I had to convince the business to change their plans. That's pretty different. I'd only been talking to technical folk. I explained to the business that instead of building an iPhone app for mortgage brokers, I should fix the core foundation of our system. At the time, iPhone apps had just come out, and I'd made a few apps in my spare time for fun. The business folk knew this because it was 2009, and we were Facebook friends, and I'd shared it on my Facebook. So they were offering to build me a lab for iPhone work, give me time to learn iOS development at work, let me build apps that would have real users. But, I came back to them and I said, we've got to focus on this core foundation first. There's just no point at all building other things on top of it. So we all realized together, me building iPhone apps isn't going to solve the critical reliability problems that are staring us right in the face every single day. We all agreed that it was critical for everyone within technology and the business to work together to get actual reliability improvements. Me just sitting at my desk, working by myself, wasn't getting results. But then suddenly there was this major update in the case. We needed to get ready for failover. That was huge. The service I was working on was an acquisition called Homeside, and we needed to do failover for the first time ever before a technical merger would happen. Rough. So we had a dramatically accelerated timeline. We needed to get ready for a major failover exercise, disaster recovery, in 3 months. If you don't pass, things won't be good. So to achieve what everyone thought was the impossible, we did 4 things. First off, we created a map of key technical and business players who were critical for reliability to improve fast. Next, we told everyone the critical issues that we needed to fix in the next 3 months, and we tracked our progress towards hitting these milestones. Thirdly, we prepped before the disaster recovery day. Sounds like common sense, but a lot of people don't do this. They just wait until their quarterly failover, give it a go. If it turns out bad, it's really not good. I've done many, many disaster recovery days in my time. It's important to prep before disaster recovery day if you do those, or to prep before disaster just strikes anyway. And lastly, you want to start small and gradually expand the blast radius of the reliability improvements. Fix the service causing the most issues first, measure the results, then do more. Divide and conquer. I love all the stories that everyone's sharing in the Slack as well. That's awesome. Please keep sharing more. It's great to hear what you've been through. So preparing for your first major chaos engineering exercise is something you'll never forget. My journey started back in 2009, and it's something I continue to practice on a daily basis. I think about disaster recovery, like major failover, as a really big chaos engineering exercise. Obviously, I'm not going to tell everyone, go into work this afternoon or tomorrow and do a failover. Like, that's not how you do it. You've got to start small. Give me an emoji reaction in the Slack if you've ever practiced chaos engineering. Who's actually done it before? Give me a wave. Who here has performed a major failover for a critical service? Are you maybe getting ready for one right now? Share in the Slack and let us know. What big things are you planning for? Great to see so many hands waving. Wow, that's awesome. Very cool. When I think back to why chaos engineering works, the main thing I always come back to is the Pareto Principle. If you solve the top 20% of your issues, you'll solve 80% of your problems. The next step is identifying your issues. So what's pulling your metrics down? What's pulling your availability metrics from a possible 6 nines to a 2 nines? Are there specific changes that occurred? Specific commits you might need to refactor or roll back? Do you have an unhealthy fleet of servers that's constantly needing to be recycled due to issues? Do you have a specific kernel issue, a firmware issue, something that's impacting a large number of your machines? Do you have a hard-coded dependency that causes an outage each time a Kubernetes pod is shut down or restarted? These are things that I've seen happen in production time and time again. But the Pareto Principle is my favorite way to identify the top 20% of issues you need to fix ASAP. The data you need to dig into is your incident metrics, your alerts, and your logs. You will find the answers if you look. Who here has heard of Chaos Monkey? Give me an emoji in the Slack if you have. I wanted to share a brief history of chaos engineering for those of you who might not have heard of it before. The Netflix Eng Tools team created Chaos Monkey way back in 2010 and actually open sourced it later on in 2012. So what Chaos Monkey does is it will shut down a random server on AWS EC2. In 2011, the Simian Army was born, which was a tool of a suite of tools that you could use, like latency injection as well. There are a bunch of different little animals that you could let loose on your infrastructure. In 2012, Netflix then shared the source code for Chaos Monkey on GitHub. That was when I first heard about it too, because at the National Australia Bank, we actually used Chaos Monkey in 2012. Then in 2014, Bruce Wong created a new role when he was working at Netflix called the Chaos Engineer. Hey, Bruce. Then Colton created FIT at Netflix, which is for failure injection. Hey, Colton. And then in 2017, Colton launches Gremlin, which is where I work now. I decided to come over here because I love doing chaos engineering, and we were the first company to actually focus on doing that. Very cool to see everyone's experiences with the monkey. I love it. All the great emojis in the chat. So here's my chaos engineering journey. A lot of the time, I honestly felt like Terminator, and it was Judgment Day. At NAB, that was the first bank in the world to practice chaos engineering as defined by Netflix. We used Chaos Monkey from Netflix when it became open source. we were moving to AWS. At NAB, we were just doing shutdown attacks. So we were just using Chaos Monkey to randomly reboot, shut down servers on EC2. Then over at DigitalOcean, I went to work there when I first escaped Australia, and we did a lot of fire drills. Then at Dropbox, I focused more on the databases and making those resilient. So I was doing a lot of process killer and shutdown attacks, mostly aimed at MySQLD as well as a SQL proxy and memcache. Then at Gremlin, we do a lot more different types of chaos engineering. Shutdown, CPU, memory, I/O, disk, process, black hole, packet loss, latency. Whoa, tons. So how do you practice chaos engineering? If you're interested in getting started with chaos engineering or advancing your skills in this area, like I've seen a lot of you in the Slack have actually done some, that's great. And it's true what it says in the Slack. I escaped Australia, but I haven't escaped my accent yet. So here are some tips to help you advance. Remember that reliability is feature zero. Make sure that you let this be known to your business teams, your technical teams. You know, if someone comes to you and says, hey, can you build the latest VR app as a layer on top of this technology that doesn't work? Say no. Like, first we need to fix the foundation. You can explain to them it's kind of just like building a really important building, a giant skyscraper. If it doesn't have a good foundation, it's not going to work. It's like putting nice curtains in or something like that on top. If you just focus on a presentation layer, it's quite dangerous, really. The whole building could crumble. Next, identify your top 5 critical systems. This is something that I like to say. Don't go for the low-hanging fruit. Figure out what your top 5 critical systems are. And ask your team, do they even know what they are? A lot of the time, people don't. But I'll give you a clue. One of them is probably the database. Another one I like to say is going to be your monitoring. Thirdly, gradually roll attacks out. So start small and gradually increase. Shutdown, CPU, packet loss, latency. Practice CE on your automation. Don't wait to see how your system handles failure. Be proactive. So just to summarize, it's fun to look back at all the success that's come along the way due to hard work, perseverance, detective work, and tons of chaos. If you do a lot of chaos engineering, for example, I found that it was important to run 3x chaos engineering experiments a week to get decent results. You'll realize it's a lot like working out to stay fit and healthy. Once a week just doesn't cut it. I was then able to get a 10x reduction in incidents in the first 3 months of a new role where I was responsible for 10,000 database machines at Dropbox using the Pareto Principle and chaos engineering. After that first big drop, 10x drop, there were no more step zeros for all the databases, and we were able to successfully keep the lights on for 500 million customers, and we were able to protect their 500 petabytes of data. We achieved big wins using chaos engineering to improve database automation reliability as well. I worked really closely with Slava to make this happen. Shout out to Slava. Chaos engineering for on-call training is also something you should totally look into. Back in 2015, this is when I started to do this. I actually hired some grads from Holberton School, and we actually used a lot of the insights that we learned along the way to train them up. We needed to figure out what exercises we would run. The way we did this, though, was we looked back at the 4 most critical incidents that had impacted our team over the past 3 months. We set up a Zoom call for everyone to join in for 2 hours. We asked one experienced engineer on the team to walk through each of the 4 incidents and recreate them in staging or production. For example, if one of the incidents was related to automation failing, then we'd inject chaos, force the automation to fail in the same way, then have them demonstrate what they would do next. If there was backup automation, is there backup automation? What are the manual steps they need to take if the automation fails? How long will it take to complete the manual steps compared to having the automation run? Often this can be minutes compared to hours. It's useful information to know upfront and train for. Manually fixing an issue for 5 hours due to automation failing is like running a marathon. Everyone has 2 hours to improve each week. This is the perfect use of this time. If you think about it, a lot of the internet's reliability stands on the shoulders of three giants, the backbone of the internet and its services. We're all using services like DynamoDB, EKS, AKS, GKE, EC2, S3, CloudFront, and more. But, we need to be looking out for reliability vulnerabilities, just like security engineers look out for security vulnerabilities. If you see something, say something. Let everyone know and get it fixed. On a final note, you could also call this a guide to how to get a CEO-sanctioned full night's sleep. When I first started doing chaos engineering work back in Australia to improve reliability, we shared our news, and there were articles that were really excited about it. The headlines read, "Engineers can finally get a full good night's sleep." So it's a pretty great way to get a CEO-sanctioned rest. Thank you so much.